Graphs of the sine and cosine functions, chapter 6, section 4. So now we're going to look at graphs of sine and cosine functions. We've talked a little bit about how they work. We've talked about the different trigonometric functions, but now we're going to actually start graphing them. And I think you're going to find that graphing these functions is actually relatively simple, at least the way that I'm going to explain it. So let's just look at trigonometric functions. So we're going to say y equals f of x is equal to sine of x. And then we're going to use cosine x, tangent x, cosecant x, secant x, and cotangent x, where x represents an angle measured in radians. Okay, so we're dealing with radians now. Remember I said that you really kind of need to focus on that side. That's okay if you're not great with radians as of yet. As long as you can get consistent on the conversions between degrees and radians, then you should be able to get into this relatively easily. So let's look at the properties of the sine function y equal to the sine of x. First of all, the domain is the set of all real numbers. The range consists of all real numbers from -1 to +1 inclusive. Now remember, we're looking at just plain sine of x, the base function sine of x. The sine function is an odd function, meaning it's symmetric with respect to the origin. Sine function is periodic. The period is 2 pi. The x-intercepts are at -2 pi, -pi, 0, pi, 2 pi, etc. in both directions. So basically multiples of pi, integer multiples of pi. Y-intercept is 0. So it crosses the x and the y-axis at 0. Obviously, it crosses the x-axis numerous points. The maximum value is 1 and occurs at x equal to -3 pi over 2, pi over 2, 5 pi over 2, 9 pi over 2. So you can basically say it starts at pi over 2 and then every 2 pi after that and every 2 pi before that because the period is 2 pi. The minimum value is -1 and occurs at x equal to -pi over 2, 3 pi over 2, 7 pi over 2, 11 pi over 2, etc. Again, you can start at 3 pi over 2 and add 2 pi or subtract 2 pi. So that's the sine function. Cosine function, very similar, y equal cosine x. The domain is the set of all real numbers. The range consists of all real numbers from -1 to 1 inclusive. Cosine function is an even function. It's symmetric with respect to the y-axis. Cosine function is periodic with a period of 2. So most of this is sounding the same. The only thing that's really changed as of this point is that the sine function was symmetric with respect to the origin. The cosine function is symmetric with respect to the y-axis. And here's where things start to change a little more. The x-intercepts are at -3 pi over 2, -pi over 2, pi over 2, 3 pi over 2, 5 pi over 2. The y-intercept is at 1. The maximum value is 1 and occurs at x equal to -2 pi, 0, 2 pi, 4 pi, and obviously multiplying, well, adding pi's and subtracting pi, adding 2 pi's and subtracting 2 pi's. Kind of making me hungry. The minimum value is at -1 and occurs at x equal to -pi, pi, 3 pi, 5 pi, and notice again, adding 2 pi, subtracting 2 pi. Now, as I said, very similar to the sine function, and this next slide will show that relationship that the sine of x is actually the cosine of x minus pi over 2. Now remember, since that pi over 2 is attached to the x and it's got a minus, that means that it's shifted to the right by pi over 2. And we see that wherever cosine x is, if you shift to the right by pi over 2, sine does the exact same thing. So we can see that cosine x is 1 when x is equal to 0. Sine x is 1 when x is equal to pi over 2. So they're really pi over 2 radians out of phase or 90 degrees out of phase. Cosine x is the sine x function shifted to the left by pi over 2. Sine x is the cosine function shifted to the right by pi over 2. So let's talk a little bit more about these. So the amplitude and period of sine and cosine. If omega is greater than 0, the amplitude and period of y equal to a sine of omega x and y equal to a cosine of omega x are given by, the amplitude is just the absolute value of a. Remember, if there's a minus there, that's just going to flip it over the x-axis. And the period t is equal to 2 pi divided by omega. Now, if you think about this, remember that omega is being multiplied by x. So when you do that, that would be a stretch or shrink in the horizontal direction. So it's a horizontal stretch or shrink. The higher the omega, or I should say, if omega is greater than 1, then it's going to shrink the graph. If it's larger than 1, sorry, if it's less than 1, then it's going to stretch the graph. And we can see here that 2 pi is 1 full period. So if omega is equal to 1, the period of it is going to be 2 pi. If omega is equal to 2, the period drops down to pi. If omega is equal to 1/2, the period increases to 4 pi. So omega greater than 1 is going to shrink it down. Omega less than 1 is going to stretch it out in the horizontal direction. So let's look at this then. If we're graphing y equal to a sine of omega x and y equal to a cosine of omega x, then the first thing we're going to do is we're going to determine the amplitude and the period of the sinusoidal function. So get our amplitude, get our period. Then, and this is where I said it's going to actually be really easy. Once we've got the amplitude and period, we're just going to divide the interval from 0 to whatever the period turned out to be, 2 pi divided by omega, into 4 subintervals of the same length. We're going to use the endpoints of these subintervals to obtain the 5 key points on the graph. The starting point, the ending point, the middle point, and then the first fifth quarter in and the third quarter in. And then we're going to plot the 5 key points and draw a sinusoidal graph to obtain the graph of one cycle. Then we can extend the graph in each direction to make it complete, depending on what we need to do with it. Okay, so let's look at an example of this, because words are words, but as soon as we start to draw it, I think it's going to come together pretty well. So let's say I want to graph y equal to 3 sine of 4x. Well, the first thing I'm going to do is find the amplitude of this. And since it's 3 sine 4x, remember that that 3 is the amplitude. What that means is that the largest value of this sinusoidal wave will be 3. The smallest value will be -3, or the minimum will be -3, the maximum will be +3. Okay, now we want to find the period. So first we notice that we've got 3 sine of 4x, so omega is equal to 4. The period is equal to 2 pi divided by that, so 2 pi divided by 4, which gives us pi over 2. Now here's where it all comes together. So the period is pi over 2, so we're going to put pi over 2 on the graph. Then what I do is I like to just divide things in half and say, okay, half of pi over 2 is pi over 4. Half of pi over 4 is pi over 8. Halfway between pi over 4 and pi over 2, or pi over 4 plus pi over 8, gives me 3 pi over 8. So now I have 5 points: 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. Now that I have those, I'm just going to give my 5 key points of my sine wave. We know that a sine wave starts at 0 when x is equal to 0. It then goes up to its maximum value at pi over 8. It then goes back down to 0 at pi over 4. It then goes down to its -3 value, its minimum value at 3 pi over 8. and then goes back up to 0 at pi over 2. So now I've got my 5 key points. So that's what I'm talking about, 5 key points. If you know the shape of a sine wave, you'll see that there are 5 key points. There's the maximum point where it crosses both points that it crosses the x-axis, the minimum point, and in a sine wave, there's where it starts at 0, where it crosses 0, and where it gets back to 0 with a minimum value and a maximum value. If you're dealing with cosine, it starts at positive amplitude, passes through 0, goes to the negative amplitude, goes up and passes through 0 and goes back up to the positive amplitude. So then when I draw this, and I'm going to give you a little trick for doing this so it actually looks like a sine wave, and to show you that this works, this is drawn by hand. I know you tend to see me use Desmos.com so that all my graphs come out looking really nice, and I don't do a lot of drawing by hand because, first of all, it's horrible trying to do that on a computer. And secondly, it's a little bit simpler for demonstrations. I don't want things to be confusing by seeing a graph that maybe didn't draw out as perfectly as we'd like. So when I draw a sinusoidal wave, the key thing to remember is that at the maximum values and the minimum values, the graph is horizontal. So your curve is passing through the maximum point and the minimum point horizontally. It's not coming at it from an angle. It's coming from the side. If you keep that in mind, your graphs will look more like sine waves and less like triangular waves. Okay, and yes, I've seen that where people basically draw these straight lines and it does not look like a sine wave at all. But you see, if you go through and make sure that you pass through the minimum and maximum values horizontally, that you get something that looks really close to a sine wave. And this was drawn by hand with a mouse onto the computer screen. And you can see how I kept it nice and horizontal at those spots, and it actually looks like what you'd expect for a sine wave. Well, let's try another example. Let's bring in cosine. So y is equal to 5 cosine pi x. First thing we're going to do is we see that 5, and that's our amplitude. We see that pi is equal to omega. So we have the period now is 2 pi divided by pi, or 2, which means we can start plotting. So we got a period of 2. So the end of this graph is going to be at 2. Half of that is 1. Half of that is 1/2. And then halfway between 1 and 2 is 3/2. So now I have my 5 points. Cosine starts high. So we've got an amplitude of 5. So it's going to start at 5. It's then going to go through 0. And then it's going to go to -5, back to 0, back up to +5. So see, those 5 points allow us to draw this. Now, as I go to do the drawing, remember, it goes through any maximum or minimum values horizontally. So as long as I keep that in mind, I should have something that looks relatively close to a sine wave. It may not be perfect, but it looks kind of like a sine wave. It's sinusoidal, right? Or a cosine wave in this case, as opposed to looking like some triangular conglomeration that we've put together. So we see that. So when graphing sine or cosine in the form A cosine omega x or A sine omega x, A gives us our magnitude, our amplitude. So that's going to give us our maximum value and minimum value. If there's a negative sign in that, then we would just flip that over and our graph would just be upside down. Omega is going to come from the coefficient of x, and we're just going to take 2 pi and divide that by omega, and that's going to tell us the length of it. Then we just split it in half, go halfway between the other one, put in our 5 points, and draw through it.